went ahead and I kind of cheated and I wrote down a couple things for you guys at the top. So we're going to find inverses in 3 different ways. So one of the ways, which is going to be on the back side of the notes, is from an equation. So if the equation's in function notation, like the f of x that we've been looking at, what I usually just tell people to do is literally just get rid of the f of x and put a y in place of that. It's a little bit easier to work with because what you do is you switch x and y, and then you get y by itself on one side of the equation. That would then be the inverse of whatever they gave you in the original problem. What we're going to do mostly on the front here is find an inverse from either a graph or a table. And so for a table, super easy, you just literally switch the x and y coordinates. So whatever you had in the original that was x, that same point, you just switch it to the y coordinate. They literally just trade places. And then on a graph, it might take you a second maybe to find a couple points and do the same thing, but we're just going to switch x and y. All right, and then all I have typed up here at the top, the range of either your relation or function, whatever you're working with, is just going to switch and be the domain of the inverse. And kind of same thing, the domain of the original is going to be the range of its inverse. So they just trade places, just like we're going to trade places with the points. Okay, so and then just remember, relation just means it doesn't necessarily pass the vertical line test. Relation means an x value could repeat. If it's a function, that just means it would pass the vertical line test and none of the x values can repeat. Okay, so literally this is all you have to do. An example 1 here. I've got a table, right? And the point, for example, we'd have -4, 3 would be a point if we had a picture of this graph. Literally, all you have to do for the inverse is switch those. So that first point was -4, 3. In the inverse, it would just be 3, -4. That's all it is. You don't change any negatives or anything like that. You just trade x and y places. So literally all I'm going to do here, I'm going to write all my x coordinates just across here for the y coordinates in the inverse. So it was -4, -2, 0, and 2. And I'm going to do the same thing for the y coordinates. You just rewrite them. We're just switching them. So it'd be 3, 5, 7, and 9. That's all you have to do. Now, to actually write the domain, what we have here, we don't have a graph, we have specific points. So I just want to remind you about this because we haven't done this for a couple of days. But if you just have specific points, I'm going to use that little brace. We don't write an interval for the domain and range. You actually have to list the coordinates. So any x value is going to be the domain. If anything repeats, which it doesn't here, then you would only have to write it once. And it doesn't matter the order. I'm literally just going to list the x values as they appear in that first table. And then the range, just your y values, kind of the same thing. And that little squiggly line, that brace, that doesn't have to be something perfect. Just make sure it's not a parenthesis or a bracket so you can kind of distinguish between them. So I'm just going to list the y coordinates of the original for the range. And then all you got to do is just switch them up. So the domain of the original will be the range of the inverse, and the range of the original will be the domain of the inverse. So just trading places. And all these are different, so I gotta list all of them. You guys are not muted. Okay. Now, function notation for an inverse. This is going to look a little bit weird. So we have f of x. This would be our original. And the inverse is written like this, f. And then it looks like a little -1 power. And you would read that as f inverse of x. So that's the notation for the inverse. So you're going to see that in the questions going forward today. So if you see that little -1, that's just going to be the inverse of the original that you have. And so my second example down here at the bottom, let me see if I can move this up. This one, we had a table. Now we're going to do this from a graph. Now, if you do have a graph, Well, let's just go ahead and do this. What I would tell you to do, this is a parabola, right? And if we were in here, I would ask you to tell me this, but I'm just going to write it down for you guys. So the domain of a parabola, any parabola, left forever, right forever, domain here, negative infinity to infinity. These points are all connected, so we want to make sure we go ahead and use an interval for that. For your range, let's come from the bottom of the top. First point I touch is going to be the vertex, and you want the y-coordinate of that point. Don't write -2, because I was tempted to do that just now. So 1 is the y-coordinate of that point. So the y values start at 1. We have a little bracket on that because it goes and touches that point. Then we're going to go up forever. This is positive infinity. Okay, so that's our original. Now, here's what I would just recommend. If you have something like a parabola, whatever, just try and grab maybe, I'm going to try and grab 5 points here that go kind of right through a corner. And you don't have to write them down or anything, but I'm just going to go ahead and jot them down. So looks like I've got the point, let's see, -6 all the way up at 9. I've got -4, 3, that vertex, -2, 1. Looks like 0, 3, and 2, 9. Now, like I said, you don't have to write those down, but it might make it a little bit easier to work with. To find the inverse and try to graph it, I'm literally just going to switch those points like I did in the table. So that first point I wrote down would become 9, -6. That second point would be 3, -4, 1, -2, 3, 0. And I hope I'm still on the screen. I'm going to have to scooch this up just a teeny bit. 9, 2. So you guys go ahead, take a second and plot those points on the graph. And then you can visually see what the vertex is going to look like. I'm sorry, the vertex, the inverse, the inverse. So just plotting these guys here. What you should kind of see form, it's going to be basically a sideways parabola is what it's going to look like. Which point am I missing? There we go. Okay, and I'm just going to kind of try and draw the curve there the best I can. So it should look like a sideways parabola. All right, that's not the most perfect graph I've ever drawn, but whatever. Now, based on what I said at the top, right, the domain and the range should switch from the original to the inverse. If you actually do the domain, for this one I just drew in red on my paper, you don't touch any x value until you get to 1, and then the rest of the graph goes to the right forever. So 1, infinity, and you guys will see those are the same, right? And then in terms of the y, this is kind of weird because it looks kind of flat, but this would gradually go up forever. This would gradually go down forever. So you would cover all the y values. So the range of that inverse should be negative infinity to infinity, which should match the domain of the original. Okay, now, I don't know if you guys will see this really well. I'm just going to draw this on the paper, but if you do have a graph of an inverse, I'm going to draw the line y equals x, which is just a perfect diagonal right through the origin. Just y equals mx plus b. I'm just drawing y equals x. Anytime you have an inverse, pull that back down so you guys can see what I wrote there. Okay, y equals x. Now, inverses are a reflection, if you remember that from geometry, over the line, whoops, I can't write this morning, y equals x. So like if I would fold that graph in half on top of that diagonal line, if I had drawn it perfectly, those two sides would match up. So anytime you have an inverse, it should be a reflection over the line y equals x. Is anybody having a question? Okay, let me flip this over. Now, on the back, we're going to do a couple of these with equations. And if we don't get through this, no big deal. We'll just get as far as we can here. All right. Now, I went ahead and there's 3 examples here. Sorry. Okay, there's 3 examples here. So the original problem's written in function notation, and all I did here was just underneath it, kind of like in a little bit lighter colored font, I just changed out the f of x for y. It's the same thing, but it's a little bit easier to work with y if you're working with notation instead of that f parentheses. So we're going to find the inverse here. Okay, so from your original problem, I'm going to look at the little tiny one I wrote. You're just going to switch x and y. So I'm going to write x equals 2y squared plus 5. So that's the inverse, but what you have to do is you have to solve for y. So we have to get y by itself on one side. So just a little algebra here. So first thing I'm going to do, I'm going to subtract 5. So we're like undoing our order of operations here. So I get rid of any addition or subtraction first. Then I'm going to get rid of any division or multiplication. So for this particular problem, I got to get rid of the 2 in front of that y squared. Just go ahead and leave this. Just go ahead and leave this like a fraction, okay? Just leave it as x minus 5. All right, over 2. Do not worry about rationalizing or whatever. Okay, now, to get y totally alone here, what I would have to do is I would have to take the square root of both sides. And just remember, if you guys introduce a square root into a problem, you got to put the plus and minus symbol in front of it. We're not rationalizing denominators or anything like that. Just leave this fraction under a square root. And I'm just going to, because it's how I always write things, I'm going to put y on the left side there. We're going to put plus and minus. You have to put the plus and minus in front of it. And then just go ahead, leave this as a fraction, x minus 5 over 2. That just whole thing under square root. Don't worry about rationalizing a denominator or anything like that. If you have a quadratic, we had a quadratic in the original problem, 2x squared plus 5, what happens is the inverse is going to be a square root of some kind. So in my second question, I'm going to give you a square root, and you guys will see the inverse will be a quadratic. Okay, so I just rewrote so it was y instead of f of x, so it wasn't in function notation. I'm going to switch x and y here. So I'm going to write x equals, and then we're going to do y plus 7 minus 10. Now, you cannot add and subtract things out from underneath the square root. So I do want to get rid of that 10 just real quick. I'm going to add 10. And so I have x plus 10. And y plus 7, all of that is under the square root. Now the deal is there, you can't just subtract the 7 out from underneath the square root. So actually the next step here is going to be to square both sides to get rid of that lovely square root. Okay, now here you're going to see my directions at the top. This just says leave in factored form. I don't want you guys to take that. You can if you're bored, but I don't need you to take that extra step to FOIL. I'm just going to leave this in factored form. So don't need to multiply out the x plus 10 squared. Just go ahead and leave it with the parentheses. It's actually a little bit easier to work with if we have to graph. And then that cancels out the square root. The only other thing you're going to do real quick, get rid of the 7, and it'll just be subtracted outside of those parentheses. So I'm going to have y equals, I'm just putting it on the left, you'd have x plus 10 squared, and then minus 7. And that, if you guys remember from our very first, maybe second unit, that's going to be a quadratic. It's just in vertex form. All right, so if you have a quadratic, the inverse is going to be a square root. If you have a square root, the inverse is going to be a quadratic. And then my last example here, this is just the equation of a line in mx plus b form. And I think we're going to stop after this today, and we'll just finish up the rest of it tomorrow in class. There's no homework or anything. We're just going to finish up this example. Okay, so here's function notation. I just rewrote it so it was y equals. Whenever you find an inverse, you're just going to switch x and y. So I'm going to write x equals 4/5 y minus 3. All right, to get rid of the 3, I'm just going to add it to both sides. ooh, I'm breaking my pencil. X plus 3 equals 4/5 y. Now, you could do this in 2 steps or 1. It's completely up to you. But to get rid of that 4/5, probably the easiest thing I could tell you to do is just multiply by the reciprocal. So the reciprocal, we just flip it over, so it'd be 5/4. And so the one thing you got to do to both sides when you do that, I would put the other side in parentheses because you have to multiply both of these terms by that 5/4. All right, so I'm going to write 5/4 x. That would basically be the slope of my inverse. And this is not a nice number, but if I multiply 5/4 times 3, just think of that as like 3/1. So I'm going to do 5 times 3, that'd be on the top, which would be 15. 4 times 1 would be 4. That doesn't reduce or anything like that, so just leave it alone. So this would be just y equals 5/4 x plus 15/4. Wouldn't be great to graph, but it's just going to be a line. So if you have a line, the inverse is also going to be a line. This is going to be mx plus b form. The slope would just be the reciprocal of the original. Okay, is anybody having a question? I'm just going to stop right there for today. So no homework, nothing like that. We'll check our 6-3 homework tomorrow. We'll finish this up, and then I'll give you the rest of the time in class to work on the assignment that goes with the inverses. So you guys are free to go when you're ready if you don't have any questions, and you have a wonderful afternoon and morning.